Hey guys, Algebra 2 here. We are still just rationalizing the denominator. So what that means is we are trying to get rid of the radical that's in the denominator, and then we will simplify from there. Everything you've already done except the getting rid of it from the denominator, which was what we did in the first video. This is just an extension of what we've done.
So let's look at day 2 notes. We only have 4 problems to do, and it's going to be pretty quick and simple. So the first thing we have to do, though, is we have to notice that we can simplify this radical. So the first thing we're going to do is we are going to break it down into a prime factorization. 8 is an even number, so it can be divided by 2. 2 times 4 is 8. 4 can be divided by 2. Now remember, when we do not have a number here, it's a 2, which means that we are going to circle groups of 2. That gets to be pulled out in front. So I'm now going to rewrite my numerator as 2 square roots of 2 over my denominator. I have a 2 that I pulled out because that's what's circled, and I have a 2 that's left inside. So the next thing we're going to do is we're going to notice that I have a radical still in my denominator. And remember that there's a 2 here. So that means I need 2 2's to break it out of jail. I only have 1, which means I need to multiply it by the square root of 2 on top and bottom. When I do that, I multiply on the outside. So there's no number here, so that means it's a 2. And then I multiply on the inside. 2 times 2 is 4. Or I can write it as 2 times 2. And then I'm going to do the same thing. 2, because I don't have a number on the outside, square root of 4. Now, the square root of 4 is 2. So I can take this. I can convert this square root of 4 to a 2. We know that the square root of 4 is 2. So this becomes 2 times 2 over 2 times 2, which means that I'm going to have 4 over 4. 4 divided by 4 is just 1. Let's look at problem 2. Again, I have a radical in my denominator, so I need to get rid of it. I need it to go away. When we don't see a number for my square root, then that means that I need 2 of them. So I need 2 5's. I have 1 5, so I have to multiply it by the square root of 5. Now I will have 2 5's. What I do to the bottom, I have to do to the top. So now I can just multiply across the top and across the bottom. So I'm going to have 20 times 5 is 100 over, I don't have another number here, so this 3 just stays outside of my square root. And I'm going to put 5 times 5. Remember, there's a little 2 there, even if it's not shown. So the square root of 100, you should know, is 10 over, this is 3 times, I have 2, I can circle that, 2 5's. So my 5's got to break out of jail. Now notice I don't have a radical in my denominator. One last thing for us to do is to recognize that 10 and 5 can both be divided by 5. So 10 divided by 5 is 2. 5 divided by 5 would be 1. So 3 times 1 is 3. And that's our answer. Number 3 gets a little more difficult as we look at it. Not really, but only because we have a number out in front of our radical. So let's look at this. It's another square root. When I don't see a number, then that means that it's a 2. So I need 2 to break it out of jail. I only have 1, so that means I need 1 more. So I'm going to multiply it by just the square root of 3, both top and bottom. Then I'm going to multiply. So when I multiply across the top, I multiply my outside number, 2 times, this could be a 1, but we're just going to leave it as 2 times, we're keeping the 2 on the outside. And then we're multiplying on the inside. 8 times 3 is 24. Multiply on the outside, so I keep my 2. 3 times 3, and I'm going to write it as 3 times 3. So now I need 2 to break it out of jail. I have a group of 2 3s. So I'm going to rewrite this as 2 square roots of 24 over 2 times 3, because I have a group of 2 3s. Now, the square root of 24 needs to be simplified. So I need to prime factor that. We're going to do that right here. 24 is an even number, so it can be divided by 2. And 12 is also an even number, and so is 6. Now remember, I need groups of 2 to break it out. So I have a group of 2. So now what that means is that this becomes 2 because of this 2 times 2 because of the 2 that I took out, square root of 2 times 3. Those did not get circled, so they stay inside my radical. And that is over 2 times 3 is 6. A little bit more simpler. We need to simplify this just slightly more. I shouldn't have written this 6. It would have been a little easier for you to be able to see maybe if I left it as 2 times 3. Because then these 2's, I have a 2 on top and a 2 on bottom, they can cancel each other out, which means that this becomes 2 square roots of 2 times 3 is 6 over 3, because this 2 canceled out this other 2 on top. So that's my final answer. We have one last one to work on. So again, I should have put a little more diversity in here, but that's all right. You guys are smart. You can get it. When there's not a number, that means there's 2. So I need 2 to break it out of jail. I only have 1, which means I need to multiply it by 1 more. What I do to the bottom, I have to do to the top. So now we're just going to multiply across. So 6 times 2 is the square root of 12. And on the inside here, I have 2 times 2. The next thing that I'm going to do is I'm going to look and see. I need 2 to break it out of jail, groups of 2. And I have a group of 2 there. But I have to prime factor my 12. So over here, I'm going to prime factor 12 as an even number, so I know that it can be divided by, by 2. 6 is also an even number and can be divided by 2. I'm going to need groups of 2 because there's no number there, so that means I need a group of 2. So I can circle my group of 2. Now I'm going to rewrite everything. So for my numerator, we simplified my 12, and we have 2. Because it got circled, it got to come out in front of my radical, but the 3 did not get circled. And here, I have a group of 2 that did get circled, and then I have nothing left in my denominator that's in a radical, which is exactly why we multiplied it by that. The last thing that we should recognize is that my 2's can cancel each other out. So all I end up with is the square root of 3. I hope you guys have a great day. Let me know if you have any questions on rationalizing denominators.